Hi everyone, welcome to math class. Today's lesson, we're talking about our properties of exponents. They all have great names. Our first one is called the product of powers. While we say they have great names, the name isn't as essential, but it is descriptive in the sense of what we're trying to do. We are talking about the product, so what we're going to be doing is multiplying two powers. X to the third times x squared. Now, fundamentally, think of what this means. X to the third power means x times itself 3 times the product of x squared means times itself 2 times. Well, now, by the same definition, the way we expanded this out, x times x times x times x times x really means x to the 5th power. Which, if you think about it, our shortcut, where we're headed today, this is the time when we add exponents. When you're multiplying, when you have a product of two powers, is when you add the exponents. So if we wanted to look at some examples, what if we had x to the 7th times x to the 4th? What are we going to get? X to the 11th. You got it. Let's look at another example. What if you had y squared times x to the 5th? As much as we'd want to say, well, yeah, that's going to be yx to the 10th, we're going to show that that can't be the case. Because think about what this meant. This meant you had two y's. This meant you had 5 x's. We don't even have 10 items there, even if we tried to make it 7. Wouldn't make any sense because it's not 7 x's. It's not 7 y's. We certainly don't have 7 x's and y's. If it's not the same base, it doesn't count. This only works when you have the same base, is when you add the exponents. Our next one is what we call the power of a power. When we have x to the 3rd power, a power, and now we're going to raise it to a power. Well, think about fundamentally what this means by the definition of an exponent. X to the 3rd power means x times x times x. Squared means we're going to say times itself, so what we're going to have is x times x times x times x times x times x. But when you look at this now, again, the definition of an exponent, we've got that same base, x, times itself 1, 2, 3, 4, 5, 6 times our shortcut. We would never want to expand this out like we're doing. This is the time when we multiply exponents. When you're multiplying two powers is when you add the exponents. When you have the power raised to another power is when you multiply. So if we wanted to look at an example here, what would happen if we had x to the 7th to the 4th? We're up here, where we had two bases, each to their own exponent, and we're multiplying them. That's when we added. Here's where one base, two exponents, the power of a power. This is when you multiply. Well, let's look at it again. Another example. What would happen if I had y squared times x to the 5th squared? Notice now, y squared unaffected. We are multiplying it, but what we have to recognize is when we have this power of a power, that's when we're going to end up multiplying. We get our x to the 10th power. But just like we said up here, when we have different bases, we can't add, we can't multiply. When we have different bases, we're done. And remember, that actually means less work for us. We don't have to think about multiplying two numbers. We don't have to think about adding two numbers. Different bases mean done. But what about our next example? X squared times x to the 5th squared. Now, you're going to notice when we get a lot more of these properties of exponents, we're going to have a lot of different ways to approach. But what's going to happen here is we're going to multiply exponents. X squared times, multiply, we're going to get x to the 10th. But notice now, since we have the same base, what are we allowed to do? Add the exponents. This meant we had 2 of them. This meant we had 10 more. X to the 12th.